Part A. 1. List the components of a DBMS. The database management system can be divided into 5 major components. They are hardware, software, data, procedures, database access language. 2. What is meant by table? In relational databases and flat file databases, a table is a set of data elements, values, using a model of vertical columns identifiable by name and horizontal rows, the cell being the unit where a row and column intersect. A table has a specified number of columns, but can have any number of rows. 3. List the data types in SQL Server. SQL Server supports the following data types categories: exact numeric, bit-int, small-int, big-int, decimal, numeric, money and small money, approximate numeric, read and float, date and time, date, datetime, datetime to, datetime offset, small datetime time, character strings, char, varchar text, Unicode character strings, nchar and varchar and text, binary strings, binary, image and binary. Other data types: cursor, hierarchy ID, SQL_variant, table, row version, unique identifier, XML, spatial and geography. 4. What is meant by first normal form? First normal form. 1NF is a property of a relation in a relational database. A relation is in first normal form if and only if the domain of each attribute contains only atomic, indivisible values, and the value of each attribute contains only a single value from that domain. 5. Define. DDL. DDL, Data Definition Language. DDL or Data Definition Language actually consists of the SQL commands that can be used to define the database schema. It simply deals with descriptions of the database schema and is used to create and modify the structure of database objects in the database. 6. What are graphical objects? Graphical object is an image in the symbol window. It can be selected, moved, modified or deleted. Graphical objects include, for example, horizontal and vertical lines, linear regression channel, Fibonacci levels, rectangle, text mark, etc. 7. What do you mean by validation? Validation is a process whereby the data entered in the database is checked to make sure that it is sensible. It cannot check whether or not the data entered is correct. It can only check whether or not the data makes sense. Validation is a way of trying to lessen the number of errors during the process of data input. 8. Define. Switchboard forms. A switchboard is a form that allows you to navigate around your Access database. The switchboard is made of buttons that you click. You can program these buttons to open forms, reports, queries, etc. Microsoft provides a switchboard wizard that allows you to define the look and feel of your switchboard. 9. Write a note on events. Database events enable an application or the DBMS server to notify other applications that a specific event has occurred. The monitor application responds to the database events by performing the actions the application designer specified when writing the monitor application. 10. What is the primary role of the data administrator? Database administrators, DBAs, use specialized software to store and organize data. The role may include capacity planning, installation, configuration, database design, migration, performance monitoring, security, troubleshooting, as well as backup and data recovery. 11. List the database tasks by development stages. Planning and strategy, analysis, design phase, implementation, maintenance. 12. What is meant by client-server database? Client-server database consists of two logical components. One is client and the other one is server. Clients are those who send the request to perform a specific task to the server, but server runs a database management system which manages the whole database. Part B. 13. Discuss about feasibility study. Feasibility study. Feasibility study can be considered as preliminary investigation that helps the management to take decision about whether study of system should be feasible for development or not. It identifies the possibility of improving an existing system, developing a new system, and produce refined estimates. It is used to obtain the outline of the problem and decide whether feasible or appropriate solution exists or not. The main objective of a feasibility study is to acquire problem scope instead of solving the problem. The output of a feasibility study is a formal system proposal act as decision document which includes the complete nature and scope of the proposed system. Steps involved in feasibility analysis. The following steps are to be followed while performing feasibility analysis minus. Form a project team and appoint a project leader. Develop system flowcharts. Identify the deficiencies of current system and set goals. Enumerate the alternative solution or potential candidate system to meet goals. Determine the feasibility of each alternative such as technical feasibility, operational feasibility, etc. Weight the performance and cost effectiveness of each candidate system. Rank the other alternatives and select the best candidate system. Prepare a system proposal of final project directive to management for approval. Types of feasibilities. Economic feasibility. It is evaluating the effectiveness of candidate system by using cost benefit analysis method. It demonstrates the net benefit from the candidate system in terms of benefits and costs to the organization. The main aim of economic feasibility analysis (EFS) is to estimate the economic requirements of candidate system before investments funds are committed to proposal. It prefers the alternative which will maximize the net worth of organization by earliest and highest return of funds along with lowest level of risk involved in developing the candidate system. Technical feasibility. It investigates the technical feasibility of each implementation alternative. It analyzes and determines whether the solution can be supported by existing technology or not. The analyst determines whether current technical resources be upgraded or added that fulfill the new requirements. It ensures that the candidate system provides appropriate responses to what extent it can support the technical enhancement. Operational feasibility. It determines whether the system is operating effectively once it is developed and implemented. It ensures that the management should support the proposed system and its working feasible in the current organizational environment. It analyzes whether the users will be affected and they accept the modified or new business methods that affect the possible system benefits. It also ensures that the computer resources and network architecture of candidate system are workable. Behavioral feasibility. It evaluates and estimates the user attitude or behavior towards the development of new system. It helps in determining if the system requires special effort to educate, retrain, transfer, and changes in employees' job status on new ways of conducting business. Schedule feasibility. It ensures that the project should be completed within given time constraint or schedule. It also verifies and validates whether the deadlines of project are reasonable or not. 14. Write short notes on class diagrams. Class diagrams are the main building block in object-oriented modeling. They are used to show the different objects in a system, their attributes, their operations and the relationships among them. The following figure is an example of a simple class. Simple class diagram with attributes and operations. In the example, a class called loan account is depicted. Classes in class diagrams are represented by boxes that are partitioned into three. 1. The top partition contains the name of the class. 2. The middle part contains the class's attributes. 3. The bottom partition shows the possible operations that are associated with the class. The example shows how a class can encapsulate all the relevant data of a particular object in a very systematic and clear way. A class diagram is a collection of classes similar to the one above. Relationships in class diagrams. Classes are interrelated to each other in specific ways. In particular, relationships in class diagrams include different types of logical connections. The following are such types of logical connections that are possible in UEmail. Association, directed association, reflexive association, multiplicity, aggregation, composition, inheritance, generalization, realization, association, association, is a broad term that encompasses just about any logical connection or relationship between classes. For example, passenger and airline may be linked as above. Directed association. Directed association refers to a directional relationship represented by a line with an arrowhead. The arrowhead depicts a container-contained directional flow. Reflexive association. Reflexive association. This occurs when a class may have multiple functions or responsibilities. For example, a staff member working in an airport may be a pilot, aviation engineer, a ticket dispatcher, a guard, or a maintenance crew member. If the maintenance crew member is managed by the aviation engineer, there could be a managed by relationship in two instances of the same class. Multiplicity. Multiplicity is the active logical association when the cardinality of a class in relation to another is being depicted. For example, one fleet may include multiple airplanes, while one commercial airplane may contain 0 to many passengers. The notation 0 asterisk in the diagram means 0 to many. Aggregation. Aggregation refers to the formation of a particular class as a result of one class being aggregated or built as a collection. For example, the class library is made up of one or more books, among other materials. In aggregation, the contained classes are not strongly dependent on the life cycle of the container. In the same example, books will remain so even when the library is dissolved. To show aggregation in a diagram, draw a line from the parent class to the child class with a diamond shape near the parent class. To show aggregation in a diagram, draw a line from the parent class to the child class with a diamond shape near the parent class. Composition. Composition. The composition relationship is very similar to the aggregation relationship, with the only difference being its key purpose of emphasizing the dependence of the contained class to the life cycle of the container class. That is, the contained class will be obliterated when the container class is destroyed. For example, a shoulder bag's side pocket will also cease to exist once the shoulder bag is destroyed. To show a composition relationship in a UML diagram, use a directional line connecting the two classes, with a filled diamond shape adjacent to the container class and the directional arrow to the contained class. Inheritance. Generalization. Inheritance refers to a type of relationship wherein one associated class is a child of another by virtue of assuming the same functionalities of the parent class. In other words, the child class is a specific type of the parent class. To show inheritance in a UML diagram, a solid line from the child class to the parent class is drawn using an unfilled arrowhead. Realization. Realization denotes the implementation of the functionality defined in one class by another class. To show the relationship in UML, a broken line with an unfilled solid arrowhead is drawn from the class that defines the functionality of the class that implements the function. In the example, the printing preferences that are set using the printer setup interface are being implemented by the printer. 15. Explain briefly on computation using queries. Aggregate functions in Dbms take multiple rows from the table and return a value according to the query. All the aggregate functions are used in select statement. Syntax minus. Select less than function name greater than, less than parameter greater than, from less than table name greater than avg function. This function returns the average value of the numeric column that is supplied as a parameter. Example, write a query to select average salary from employee table. Select avg, salary, from employee. Count function. The count function returns the number of rows in the result. It does not count the null values. Example, write a query to return number of rows where salary greater than 20,000. Select count asterisk from employee where salary greater than 20,000. Types minus. Count asterisk counts all the number of rows of the table including null. Count column underscore name count number of non-null values in column. Count distinct column underscore name count number of distinct values in a column. Max function. The max function is used to find maximum value in the column that is supplied as a parameter. It can be used on any type of data. Example minus write a query to find the maximum salary in employee table. Select max salary from employee. Sum function. This function sums up the values in the column supplied as a parameter. Example: write a query to get the total salary of employees. Select sum, salary, from employee. stddev function. The stddev function is used to find standard deviation of the column specified as argument. Example: write a query to find standard deviation of salary in employee table. Select stddev, salary, from employee. Variance function. The variance function is used to find variance of the column specified as argument. Example: select variance, salary, from employee. An operator is a reserved word or a character used primarily in an SQL statements where clause to perform operations, such as comparisons and arithmetic operations. These operators are used to specify conditions in an SQL statement and to serve as conjunctions for multiple conditions in a statement. Arithmetic operators. Comparison operators. Logical operators. Operators used to negate conditions. SQL arithmetic operators. Assume variable A holds 10 and variable B holds 20, then minus. Show examples. Operator description example. Plus addition adds values on either side of the operator. A plus B will give 30. Subtraction subtracts right-hand operand from left-hand operand. AB will give 10. Asterisk multiplication multiplies values on either side of the operator. A asterisk B will give 200. Division divides left-hand operand by right-hand operand. B A will give 2. Modulus divides left-hand operand by right-hand operand and returns remainder. B% A will give 0. SQL comparison operators. Assume variable A holds 10 and variable B holds 20, then minus. Operator description example. Equals. Checks if the values of two operands are equal or not. If yes, then condition becomes true. A equals B is not true. Exclamation mark. Equals checks if the values of two operands are equal or not. If values are not equal, then condition becomes true. A equals B is true. Less than greater than checks if the values of two operands are equal or not. If values are not equal, then condition becomes true. A less than greater than B is true. Greater than checks if the value of left operand is greater than the value of right operand. If yes, then condition becomes true. A greater than B is not true. Less than checks if the value of left operand is less than the value of right operand. If yes, then condition becomes true. A less than B is true. Greater than equals. Checks if the value of left operand is greater than or equal to the value of right operand. If yes, then condition becomes true. A greater than equals B is not true. Less than equals checks if the value of left operand is less than or equal to the value of right operand. If yes, then condition becomes true. A less than equals B is true. 16. Discuss about joins with examples. SQL join. A join clause is used to combine rows from two or more tables, based on a related column between them. Let's look at a selection from the orders table. Ordered customer at order date 10308 2 199609 18 10309 37 199609 19 10310 77 19960920. Then, look at a selection from the customers table. Customer at customer name, contact name, country. Exclamation mark. Less than checks if the value of left operand is not less than the value of right operand. If yes, then condition becomes true. A less than B is false. Exclamation mark. Greater than checks if the value of left operand is not greater than the value of right operand. If yes, then condition becomes true. A greater than B is true. 1 Alfred's Fotokust Maria Anders Germany. 2 Ana Trujillo Emperedados y Hilados Ana Trujillo Mexico. 3 Antonio Moreno Taqueria Antonio Moreno Mexico. Notice that the customered column in the orders table refers to the customered in the customers table. The relationship between the two tables above is take customer column. Then, we can create the following SQL statement that contains an inner join that selects records that have matching values in both tables. Example. Select orders, ordered, customers, customer name, orders, order date from orders. Inner join customers on orders, customer equals customers, customer try it yourself. Ordered customer name, order date. 10,308 Ana Trujillo Emperedados y Hilados September 18, 1996. 10,365 Antonio Moreno Taqueria November 27, 1996. 10,383 Around the Horn December 16. Here are the different types of the joins in SQL. Inner join returns records that have matching values in both tables. Left outer join returns all records from the left table and the matched records from the right table. Right outer join returns all records from the right table and the matched records from the left table. Full outer join returns all records when there is a match in either left or right table. 17. Write short notes on procedural languages. SQL is an extension of SQL language that combines the data manipulation power of SQL with the processing power of procedural language to create super powerful SQL queries. SQL means instructing the compiler what to do through SQL and how to do through its procedural way. SQL is designed for seamless processing of SQL statements, enhancing the security, portability, and robustness of the database. Similar to other database languages, it gives more control to the programmers by the use of loops, conditions, and object-oriented concepts. Full form of SQL is Procedural Language Extensions to SQL. In this tutorial, you will learn architecture of SQL, advantage of using SQL, architecture of SQL. The SQL architecture mainly consists of following three components. 1. SQL block. 2. SQL engine. 3. Database server SQL block. This is the component which has the actual SQL code. This consists of different sections to divide the code logically. Declarative section for declaring purpose, execution section for processing statements, exception handling section for handling errors. It also contains the SQL instruction that used to interact with the database server. All the SQL units are treated as SQL blocks, and this is the starting stage of the architecture which serves as the primary input. Following are the different type of SQL units. O anonymous block. O function. O library. O procedure. O package body. O package specification. O trigger. O type. O type body. SQL engine. SQL engine is the component where the actual processing of the codes takes place. SQL engine separates SQL units and SQL part in the input as shown in the image below. The separated SQL units will be handled by the SQL engine itself. The SQL part will be sent to database server where the actual interaction with database takes place. It can be installed in both database server and in the application server. Database server. This is the most important component of SQL unit which stores the data. The SQL engine uses the SQL from SQL units to interact with the database server. It consists of SQL executor which parses the input SQL statements and execute the same. Below is the pictorial representation of architecture of SQL. SQL architecture diagram. Advantage of using SQL. 1. Better performance, as SQL is executed in bulk rather than a single statement. 2. High productivity. 3. Tight integration with SQL. 4. Full portability. 5. Tight security. 6. Support object-oriented programming concepts. 18. Discuss about distributing application. A distributed DBMS manages the distributed database in a manner so that it appears as one single database to users. In the later part of the chapter, We go on to study the factors that lead to distributed databases, its advantages and disadvantages. A distributed database is a collection of multiple interconnected databases, which are spread physically across various locations that communicate via a computer network. Features: databases in the collection are logically interrelated with each other. Often they represent a single logical database. Data is physically stored across multiple sites. Data in each site can be managed by a DBMS independent of the other sites. The processes in these sites are connected via a network. They do not have any multiprocessor configuration. A distributed database is not a loosely connected file system. A distributed database incorporates transaction processing, but it is not synonymous with a transaction processing system. Distributed Database Management System. A distributed database management system, DBMS, is a centralized software system that manages a distributed database in a manner as if it were all stored in a single location. Features: it is used to create, retrieve, update, and delete distributed databases. It synchronizes the database periodically and provides access mechanisms by the virtue of which the distribution becomes transparent to the users. It ensures that the data modified at any site is universally updated. It is used in application areas where large volumes of data are processed and accessed by numerous users simultaneously. It is designed for heterogeneous database platforms. It maintains confidentiality and data integrity of the databases. Factors encouraging DBMS. The following factors encourage moving over to DBMS-. Distributed nature of organizational units. Most organizations in the current times are subdivided into multiple units that are physically distributed over the globe. Each unit requires its own set of local data. Thus, the overall database of the organization becomes distributed. Need for sharing of data. The multiple organizational units often need to communicate with each other and share their data and resources. This demands common databases or replicated databases that should be used in a synchronized manner. Support for both OLTP and OLAP. Online transaction processing (OLTP) and online analytical processing (OLAP) work upon diversified systems which may have common data. Distributed database systems aid both these processing by providing synchronized data. Database recovery. One of the common techniques used in DBMS is replication of data across different sites. Replication of data automatically helps in data recovery if database in any site is damaged. Users can access data from other sites while the damaged site is being reconstructed. Thus, database failure may become almost inconspicuous to users. Support for multiple application software. Most organizations use a variety of application software, each with its specific database support. DBMS provides a uniform functionality for using the same data among different platforms. Advantages of distributed databases. Following are the advantages of distributed databases over centralized databases. Modular development. If the system needs to be expanded to new locations or new units in centralized database systems, the action requires substantial efforts and disruption in the existing functioning. However, in distributed databases, the work simply requires adding new computers and local data to the new site and finally connecting them to the distributed system, with no interruption in current functions. More reliable. In case of database failures, the total system of centralized databases comes to a halt. However, in distributed systems, when a component fails, the functioning of the system continues, maybe at a reduced performance. Hence, DBMS is more reliable. Better response. If data is distributed in an efficient manner, then user requests can be met from local data itself, thus providing faster response. On the other hand, in centralized systems, all queries have to pass through the central computer for processing, which increases the response time. Lower communication cost. In distributed database systems, if data is located locally where it is mostly used, then the communication costs for data manipulation can be minimized. This is not feasible in centralized systems. Adversities of distributed databases. Following are some of the adversities associated with distributed databases. Need for complex and expensive software minus Dbms demands complex and often expensive software to provide data transparency and coordination across the several sites. Processing overhead minus even simple operations may require a large number of communications and additional calculations to provide uniformity in data across the sites. Data integrity minus the need for updating data in multiple sites pose problems of data integrity. Overheads for improper data distribution minus responsiveness of queries is largely dependent upon proper data distribution. Improper data distribution often leads to very slow response to user requests. 19. Write short notes on web as a client-server. In client-server computing, the client requests a resource and the server provides that resource. A server may serve multiple clients at the same time while a client is in contact with only one server. The different structures for 2-tier and 3-tier are given as follows: minus 2-tier client server structure. The 2-tier architecture primarily has two parts, a client tier and a server tier. The client tier sends a request to the server tier and the server tier responds with the desired information. An example of a 2-tier client server structure is a web server. It returns the required web pages to the clients that requested them. An illustration of the 2-tier client server structure is as follows: minus advantages of 2-tier client server structure. Some of the advantages of the 2-tier client server structure are minus. This structure is quite easy to maintain and modify. The communication between the client and server in the form of request-response messages is quite fast. Disadvantages of 2-tier client server structure. A major disadvantage of the 2-tier client server structure is minus. If the client nodes are increased beyond capacity in this structure, then the server is not able to handle the request overflow and performance of the system degrades. 3-tier client server structure. The 3-tier architecture has 3 layers, namely client, application and data layer. The client layer is the one that requests the information. In this case it could be the GUI, web interface etc. The application layer acts as an interface between the client and data layer. It helps in communication and also provides security. The data layer is the one that actually contains the required data. An illustration of the 3-tier client server structure is as follows: minus advantages of 3-tier client server structure. Some of the advantages of the 3-tier client server structure are minus. The 3-tier structure provides much better service and fast performance. The structure can be scaled according to requirements without any problem. Data security is much improved in the 3-tier structure. Disadvantages of 3-tier client server structure. A major disadvantage of the 3-tier client server structure is minus. 3-tier client server structure is quite complex due to advanced features system. Part C. 20. Describe about converting class diagrams to normalized tables with examples. Converting class diagrams to normalized tables. One-to-many relationships are easily converted. Just make sure that the key field of T1 table is a foreign key of T-many table. Many-to-many relationships should be split into two one-to-many relationships. The new table should hold the primary key fields of the original table, which forms the primary key of the new table. The database can be represented using the notations, and these notations can be reduced to a collection of tables. In the database, every entity set or relationship set can be represented in tabular form. The diagram is given below. There are some points for converting the diagram to the table. O entity type becomes a table. In the given diagram, lecture, student, subject and course forms individual tables. O all single valued attribute becomes a column for the table. In the student entity, student_name and student_id form the column of student table. Similarly, course_name and course_id form the column of course table and so on. O a key attribute of the entity type represented by the primary key. In the given diagram, course_id, student_id, subject_id and lecture_id are the key attribute of the entity. O the multivalued attribute is represented by a separate table. In the student table, a hobby is a multivalued attribute. So it is not possible to represent multiple values in a single column of student table. Hence we create a table stud_hobby with column name student_id and hobby. Using both the column, we create a composite key or composite attribute represented by components. In the given diagram, student address is a composite attribute. It contains city, pin, /, street, and state. In the student table, these attributes can merge as an individual column. O-derived attributes are not considered in the table. In the student table, age is the derived attribute. It can be calculated at any point of time by calculating the difference between current date and date of birth. Using these rules, you can convert the diagram to tables and columns and assign the mapping between the tables. Table structure for the given diagram is as below. Figure table structure. 21. Explain the queries with multiple tables with suitable examples. Displaying data from multiple tables. The related tables of a large database are linked through the use of foreign and primary keys, or what are often referred to as common columns. The ability to join tables will enable you to add more meaning to the result table that is produced. For n number tables to be joined in a query, minimum n1 join conditions are necessary. Based on the join conditions, Oracle combines the matching pair of rows and displays the one which satisfies the join condition. Joins are classified as below. Natural join, also known as an equijoin or a simple join, creates a join by using a commonly named and defined column. Non-equality join joins tables when there are no equivalent rows in the tables to be joined, for example, to match values in one column of a table with a range of values in another table. Self-join joins a table to itself. Outer join includes records of a table in output when there's no matching record in the other table. Cartesian join, also known as a Cartesian product or cross join, replicates each row from the first table with every row from the second table, creates a join between tables by displaying every possible record combination. Natural join. The natural keyword can simplify the syntax of an equijoin. A natural join is possible whenever two or more tables have columns with the same name and the columns are join compatible, i.e., the columns have a shared domain of values. The join operation joins rows from the tables that have equal column values for the same named columns. Consider the one-to-many relationship between the departments and employees tables. Each table has a column named department_id. This column is the primary key of the departments table and a foreign key of the employees table. Select t.first_name d.department_name dname from employees natural join departments t. First_name dname. Mila dept1 John dept1 Martin dept2 Edwin dept2. The below select query joins the two tables by explicitly specifying the join condition with the on keyword. Select t.first_name d.department_name dname from employees join departments t. On e.department_id equals t.department_id. There are some limitations regarding the natural join. You cannot specify a log column with a natural join. Also, columns involved in the join cannot be qualified by a table name or alias.